my next question goes to Tony. I want to, referring to your IEEE paper, what are some of the ways you deal with reducing expenses on cooling for your cabinets and equipment shelters?
Hi there. Okay, and I'm audible. You can hear
Yes,
me.
we can hear you. Yes.
Okay, wonderful. So my IEEE paper just opened up the discussion at a time when a lot of people were putting up 2 air conditioners on the wall for redundancy, and either disabling economizers or using them, or didn't know how they should be set properly. So it was an exploration into free cooling. And first of all, free cooling may be an option for your for your area, for your location. It has a location variables. You may have the environment or the weather where you live may favor or allow you to do free cooling. I think most of Canada would qualify that way. Now, nobody thinking that we're skiing up here all year round. No. But the southernmost part of Ontario is really on the same latitude as the northernmost part of California. So we do reach kind of south. But by location, I also mean, do you have clean air? Are you next to a farmer's field that would foul your filters, or next to a road surface with lots of dust and maybe even salt spray in the winter? These are all considerations. But the bottom line is that mechanical cooling has a 3-to-1 advantage for heat removal. So you have to burn 1,000 watts to remove 3,000 watts of heat. Whereas free cooling would have 15 or 20 ratio to 1 ratio of, you burn 200 watts on a fan to remove 2,000 watts of heat, or even more, 4,000 watts. So the first thing you have to realize, if you don't have a lot of heat, then maybe the mechanical versus free cooling modes won't make that much of a difference. But as your heat load increases, your ability to save more money using free cooling increases as well. So what's the difference then? One thing we have to let go of is that electronics is not a human, so it doesn't need a very specific and strict temperature control. What we can do is increase the don't care range. So if the heating is now for this is not human comfort, this is equipment comfort, and most of the equipment I deal with has tolerances up to 40 degrees Celsius or beyond. Power plants 55 degrees Celsius. A lot of the BBUs and radio equipment we use are also 55-degree rated with no reductions in performance. So the most sensitive box in a cell site, for instance, would be the battery. A lead battery certainly doesn't want to live at 40 degrees and will be rather short-lived if you leave it there. Okay, so the free cooling algorithms take advantage of nighttime air to cool things down and average it down. And a lot of my testing and data show that a 4-day moving average, where you can tolerate higher temperatures during the day and bring them back down at night, still leave you with a 25 degrees Celsius average, which is great for the batteries. If a human visits the site, you have to have a way to hit comfort mode easily, so that now you adjust your parameters so that, for instance, if you have an air conditioner, you can operate at 24 degrees while that person's there with, let's say, a 3-hour timer, or 19 degrees Celsius if it's a heating issue and you want to give some creature comforts. So that the control algorithms change, because now you're really working where your indoor temperature is going to be like 3, 4, 6 degrees above outdoor ambient, depending on the math here, and then the CFM and so on of the fan. Whereas with an air conditioner, you have a flat line. So what does that change? That also changes the algorithm you have to use and the way you use to detect that there's a problem. So if your air conditioner fails and you're sitting there at a solid 25 degrees all the time, some of you are going, 25, I'm at 72 Fahrenheit or like 20 degrees. Well, you're refrigerating your equipment. Does it have to be there? It doesn't. So let's say you're at 25 or even 27 degrees with your air conditioner. As soon as it fails, the temperature starts to rise. You could have a simple alarm contact that says at 32 degrees, bang, it's an alarm. But you can't do that with free cooling. If you have a 32-degree day outside, it might be 35, 36 degrees inside, depending on your fan. So you have to account for that. So we have more complex algorithms to trend the temperature in the shelter and then act on an excursion, which might be a delta T by delta time type, dt by dt type of algorithm. So you also have to change your filters more often. You have to have filter replacements. Usually I recommend that this be taken care of up here in the Northern Hemisphere by May, by the end of May, before the heat really comes in with a vengeance. And that way you have your cleanest filter with the least amount of restrictions. And by October, when things are starting to cool off again, if your filter's fouled with a lot of fluff and things that get drawn in, well, that's okay, because the fan doesn't have to speed and operate as quickly. I did mention the fan speed. We don't do on and off. That annoys neighbors. That's anybody can quickly understand and hear a fan turning on and off. But if you vary its speed gently, along with which is governed by the conditions, then you can it just finds its stable point and operates there. So that's a quick, maybe not so quick overview of free cooling. You can still have an air conditioning system there that cuts off the top excursion. So if you won't accept anything past 35 degrees, let's say, that's where the air conditioner turns on. But now you have a way where most of the time you're operating on free cooling, and therein lies your energy savings. 5G's putting more, again, putting a lot of radio BBU heat into the shelters. We're up around 4,000 watts now, getting there. And so it's not as high as the old amps days when when all the radios and power and everything was in the shelter and we needed 5-ton air conditioners, but that's gone. But 4,000 watts is about where we're into now. Thank you.